Okay. Welcome to everyone, especially to our international guests, and we will hear more from you afterwards. I just want to introduce this seminar, and this is part of an international project we have been running for the last 4 years, and we are about to finalize this project now by the end of October. It's called CAPSAN. It means Capacity Building in Sustainability and Environmental Management, and it's funded by the European Commission through the program Erasmus+. And here you see our partners. It's a technical university in Delft. We have 2 professors there from Delft today. It's from University of Technology in Lisbon, and it's NTNU. NTNU is leading this project. I am the project leader, and with me I have Hailey Knudsen, who is a PhD here at our Department of International Business in Ålesund. I just introduced you, Hailey, as well. And we have partners in Uganda. It's Makerere University. It is MUBS and MUST. So we have 3 universities in Uganda. We have 2 from Nepal. It's Kathmandu University and Tribhuvan University, Tribhuvan and Kathmandu. And we have 2 institutes in India. It's Indian Institute of Technology. It's the largest institute in India. And we have this, which is the Tata Institute of Social Science. In addition, we have also associated partners in Nepal and in Uganda. So it's a very interesting project. We have achieved some good results already, and this is what we have been doing the last 4 years. It aims to create a multi-regional network for knowledge exchange and capacity building in sustainability and environmental management. And we have delivered training material that has been used for university students and university staff and university students. We have adapted courses at each partner university based on this model that I will show you. And we have now also prepared an online course that will be open for everyone. And we have video lectures. I think there are about 9 videos we have prepared.
Yeah, 9. Yeah.
And we have industry training for local companies. And the idea is to bridge the gap between academia and industry in partner countries, especially. This is what we call the CAPSAN model for sustainability tools and methods, and we have divided it into 4 levels, depending on the size of the system we are operating on or looking into. The first level is on the processes. Processes to be used in companies. There can be processes where we have gluing, for example, for some pieces to put them together. It could be cleaning of water, it could be treatment of waste, energy, where we look into the different processes in a production value chain in-house in a company. And here we have some methods, input-output analysis on a small level. We have material flow analysis that can be used on a country level, but it can also be used on the small process where we look at the input and output and look at the different materials that are used. Cleaner production is also an international recognized methodology where we go into the different processes and see where we can improve it. So this is on the first level. On the second level, we look at the products. Then it's not only one process in one company, but to get the process, especially to get the product, and to get the product out to the consumers, there are many processes involved. So then we look into the life cycle of the product or the entire value chain, from resource extraction to the end of the lifetime of this product. So here we have methodologies like life cycle assessment, supply chain management, carbon footprints of products, environmental product declarations, and design for environment, to mention a few of these methods that are used to improve products along the value chain. And if you go to a higher level, and we have changes here, we have seen this change also over time when these models have been, or methodologies have been developed. On the third level, then we go into the organizational level, look into one company and say, what do we need to get a change in strategic thinking in a company, for example, or organizational change improvements. And here we have methodologies like environmental management systems, environmental performance evaluation, key performance indicators, global reporting initiatives, life cycle management, and sustainable business models. These are methodologies we have addressed in this training material that we have developed through the project. And then on the fourth level, we talk about the system change improvements. How can we look into larger systems? For example, a university, it can be a city, it can be a region, and we use different types of methodologies here as well. And we have chosen to look into the models of industrial ecology. That means we design industrial processes according to ecological principles. We have corporate social responsibility, and we have used systems engineering. How to make systems more sustainable. So we see that by using these different methodologies in a stepwise approach, we are on a journey towards more sustainable practice. So, I mentioned the consortium. Here we see they are listed, and we also see where we can find them. I was just looking at this yesterday. We can almost take a line between Norway and Delft and Lisbon, and we can almost make a line from Nepal, India to Uganda. And through this program, we have visited all our partner universities, and we have also had our partners visiting Europe, the partners from Africa, from Nepal and India. They have visited our universities and also industry in our countries. So this is just a picture from when we visited Fiskestrand shipyard. I think there there should be, but I'm not sure if it worked, in fact. Ska vi se? Tested it last night, I think. Let me see. We can see.
Do you want me to find it really quick, or you're fine? You just continue.
I can continue, and then we can run it when we have our lunch.
Okay.
Yeah.
Okay. Yeah.
So, as I said, the objectives, it's to expand sustainability and environmental management capacity at university in Uganda, India, and Nepal in order to build knowledge and practical experience for sustainable poverty reduction, development, and innovation. So you see, we want to turn the students into a new responsible workforce for sustainable growth. We want to engage and train local industry partners, and we want to strengthen the relationship. And this relationship is very important because it's not enough to work at Sunnmøre anymore. We need to look out, and we had an interesting presentation from Torgeir Reve last week, and he said, Sunnmøre, you must not be too concerned about what's going on in our small region here. We need to look out, and we need to go to Asia and Africa to find new markets. So this is exactly what we have done now. We have established very good relationships and networks in these countries. So just to give you an impression of what we have been doing, we have had a lot of seminars, made material packages, we have developed master courses on different partner universities, And these material packages and the lectures are all available at our webpage. So everyone can go into I show it on the next slide, the link to our webpage. And these are the training seminars that we have designed for and held for local companies. And we also show best practice in each of these partner countries. And we have had student from Nepal. He was working here at ORIM, the waste, the inter-regional waste company. And he is now doing his master thesis in Nepal. And we have a co-supervisor here. Alan is helping him in his master thesis, and he will bring experience from how we do waste treatment in our region and contribute to a change in Nepal. So it's a part of our practical activities. So this was a short introduction. This is our website, yes, and this is the Facebook. And also you can also find the link. Do we find the link to our online course here now or
not yet? But
not yet, because this is what we have discussed this morning, how to organize it. Yes, so this was a short introduction. We will now have a short break to get some food, and we will continue afterwards with a presentation by Fernanda and Margot and Eisbert.
Thank you.
Yes, I hope you found the food and everything. So I would like now to introduce our first speaker, and it's Fernanda Margarido from the Institute of Superior Técnico at the University of Lisbon. So please, Fernanda.
Thank you very much. Thanks to all for coming, and I hope you enjoy my presentation, because it is a very little technology, because I am from the area of technology, from the treatment of residues, not all of you as from more things like sustainability, and I was working only in this area of sustainability since 5 years ago. My presentation is about the problem of the materials in supply chain when you are doing some products, and it is entitled Material Supply Chain and Circular Economy. All of us knows that human activity is leaving a mark, an intrusive and persistent mark on the ecosystems where we live and on which we depend. And this mark is seen by all of us due to the techno-fossil materials that are new rocks, new minerals that are persistent in the future, and this is a big problem for the humanity. And this is why some geologists says that you are entering a new geological area, the Anthropocene. I think you remember you are in the Holocene, and some people said you are already in the Anthropocene. And why this happened? Because we are living in a linear economy. And this linear economy, this is the problem that is to make use and dispose. You produce, you have the raw materials from normally natural resources, and after you do the extraction, the production, and you have the use, and after the residues, and the residues not enter another time in the chain of materials. But this linear economy is not the best way for living, because this is only possible if the population is not growing. But we know that the population in the world is increasing, and you know that next year we are in the world more or less 7.8 billion of people, and in 2050 we are 9.7 billion of people. It's impossible to live with same system with so much population, because we are well-being, we are many materials, many products, and these products are made with materials. And for producing these materials, it is necessary more and more quantity of materials, and in next year, the materials for our system of life are 65 billion of ton of materials to produce our products, and in 2050 will be 186 billion of tons of materials. Of course, that for producing these products, we need the transformation, manufacturing, and the emissions are increasing also, and you change from in 1990 we have more or less 34 billion tons, and in 2015 will be 80 billion tons of emissions to the atmosphere. Because this is the great problem, because in the linear economy the focus is the management of throughput of the flows. And it is necessary to understand why it is happening, because we are living in a society of high consumer, and you have here a graph of Professor Ashby. I think you know, probably not, because it's the area of materials. It's from Cambridge in the United Kingdom, with material flow analysis in 2014. The 23 more important engineering materials that are used for our consumer. And we have the three more important families: metals, polymers, and ceramics. And this is a logarithmic scale. And we have the annual world production per year in 2014. And we have, for comparison, we have the here oil and gas on the left hand. For comparison, the oil and gas produced, and you see still we produce this high quantity. This is normal, this is for the infrastructures, and all the other non-ferrous materials are 100 of granders, 8 like that in terms of this. If you compare the polymers, the 5 families of polymers is more or less the same quantity of all the other non-ferrous materials. This is a huge quantity of materials, and we know these are they are natural raw materials. It is impossible to have another time these materials. The other problem is we know that we have a great evolution of the composition of wood products. All of us remember the old lamps, the incandescent lamps, where we know in yellow, dark yellow, the metals that were used for producing this lamp. The only critical raw material, and after we speak about this, was the tungsten that are used in this lamp. The new lamps, the smart lamps with high efficiency, we have already 7 raw materials. We are increasing the quantity of raw materials for this new type of products. The other is this beautiful found from the 60s, any critical raw material, and our mobile phones. This is 23 new raw materials. It is impossible to work like this time, because it is necessary to multiply by the quantity of mobile phones in the world. And the engines of the aircrafts is in the old, in the 60s, there's also one critical raw material, the tungsten, and new engines are all these new raw materials. This is the big problem in the linear economy. This is why I said that we are impact of the human activity in the environment. And I think you know this equation, due to common Ehrlich and Olden equation. They are biologists, and they said that the impact of human activity is due to 3 factors. The population, and we are increasing a lot. The affluence, it's related with the wealth of the people. Of course, the resource depletion and the technology. And you can measure the impact that you are doing in the society. It's impossible to live with this system. And this is why we are entering in a new model of economy. This is the circular economy. This is an industrial economy that, in order to promote high quantity of materials, promotes the great resource productivity to increase the lifetime of the product in use, instead to reduce this lifetime, aiming to reduce the wastes and to avoid the pollution. I like very much this graphic, it's different from the graphic normal from Ellen and MacArthur. This is from Professor Stale, and this is from Nature 2016. And we have the 3 loops of the circular economy. We have the extraction of raw materials. It is necessary to have a great quantity of innovation, but we have the 3 little loops. We have the reuse, repair, and remanufacturing before going to recycle. Because if you reuse and pay attention that the loop of reuse, it can be made at a regional, a local, in our houses when our washing machine is not working, we can go to the shop to repair our washing machine. It is a local. You are going from local to regional when you need to remanufacturing, because when remanufacturing sometimes you need more pieces and it is necessary to go to a global world to have these materials. And I think this is, for me, a good representation of the circular economy in terms of the materials and products. This is why reuse what you can, repair what is damaged, remanufacture what you cannot be repaired, and recycling we cannot be reused. This is why recycling when you are going from the linear to circular economy, it's so important. And the other question is the changing of the waste management, the hierarchy of the solutions in waste management, and before go to the recycling, it is necessary to manage the prevention and the reduction of production of residues, because it is necessary to reduce. This is a great discussion about this, because the recycler says, if I don't have residues, I can't recycle. But the question is to reduce the production of residues. And this is why this is the podium of the winners: reduce, reuse, and after only the recycling process. Recycling of materials. I have 2 questions. Why do we need to recycle? Why should we want to recycle? This is a question of urgency. And we are speaking about these 4 topics: the physical availability, the geopolitics, economics, the environmental and social issues. And after, what are the obstacles and problems for recycling the materials? Urgency. We know that the materials are done with ores, natural raw materials. And we know these natural raw materials are decreasing in the ecosystem. And I have here a graph from the United States Geological Survey with data, recent data, and taking as 0.0 the 60 years, you see the evolution is 350% of increase, for example, in steel. This is more or less in basic metals, but there we have some critical metals like the RE, rare earth elements, need for the IT technology, and the cobalt, very, very important as you know, and the gallium, very important for the mobile phones. And the evolution is the same. These metals are increasing a lot in the manufacturing of the new products. And this is the depletion of mineral raw materials. Another question is the availability of these materials. And we have this graph where you see we only know these reserves, and these reserves can increase the evolution, but it depends on the cost of recovery related with the technology that you use, and we don't know the quantity of these materials. This is the uncertainty of these materials. And this is the available resources that can play with the price and the volatility of this question. The other question is the ores, the content, the grade of the ores are decreasing. You can see the general trend of the ores. For example, the ores the ore grades in Australia was, in terms of copper, in the past was 25%. In this moment, we are mining some copper with 1–2% of copper. This is a brutal consequence in terms of the so great mining of these minerals. The other problem you can see, it's a great problem. The lifetime, the third called the lifetime of some metal. This graph can only be analyzed if you maintain our lifetime and you consume life we consume today, the lifetime of these metals. Pay attention, for example, to silver. 13 years. We have from natural raw materials, we have silver only for 13 years. For example, aluminium is a great, the lifetime is very high. Why? Because we know that aluminium was the first metal to be recycled due to the Cold War between the United States and the former Soviet Union. And this is why it was the first metal to be exported. This is why recycling is so important. The other question is geopolitics. And this is more related with the critical raw materials. The critical raw materials that there are different lists of critical raw materials, and the critical raw materials for the United States is not the same like is for Europe. It depends of the relationships between countries, but for Europe we have here the geopolitics of these metals. And you see this area is in Africa, where we have a great concentration of this type of raw materials, and the more important raw materials in terms of the new technologies. And this is the great problem for the countries, because due to this problem we have high volatility of prices. For example, 2 weeks ago, my student was working with the neodymium. It is a critical raw material, and we are going to see the price, because cobalt is the more important, and 95% of cobalt is coming from the Democratic Republic of Congo, and you know this is a country in war, and the price was 65 euros per kilo. 2 weeks ago was 35 kilos. The volatility is very high. It's impossible for a company to work with this volatility of prices. And here you can see the list. This is the third list, because this list is renewable every 2 years from the European Union. This is from 2017, and the critical raw materials, there are a threshold in terms of economic importance, and the older list was in 2. In this moment we are in 2.8, and the supply risk, depending on the wars and these countries, is 1. And these are, in this moment, they are 29 critical raw materials for the development of the industries in the European Union, because we don't have these metals. And the recycling is more or less 0 in terms of these elements. Economics. We have a growing demand for these critical raw materials. And because I don't know, I know that you are from different areas, I put the areas in industry that use these critical raw materials. For example, in wind turbines, this is neodymium for the rotor of the motor to have the difference. In phosphorus and luminescences, for example, for the lamps of intelligent lamps, we need a high quantity of lanthanum, cerium, and this is very difficult with this. In the catalysts, the new catalyst of the cars with the palladium, this is and also with new technologies like the nanotechnology. Problems with increasing production, because we are increasing the production, resulting, of course, the rising price and high volatility, but recycling is also very important, because can help to stabilize prices, because if you inject in the market more quantity of these metals, the price is equilibrated, and can reduce imports and create jobs. This is very important for the European society, where we know that jobs are a great problem. Environmental issues. When we compare the recycling production of materials with the primary, in this case metal production, we know that the primary production coming from the ores has high energy consumption, land degradation, bad working conditions. All of us knows the problems in the mines with these conditions, pollution, and in extreme cases, violence, oppression, and slavery. And analyzing the carbon footprint by primary production, you can see the high carbon footprint of these metals, being aluminum, the carbon footprint. In terms of pollution, recycling is good because it can reduce the energy consumption, because as you know, the energy of the materials is accommodated in the material. And the aluminium, for example, for produce aluminium coming from the ore that is bauxite, it is necessary 1070 degrees for melting the aluminium. Of course, this energy is embodied in the metal. When you are doing the recycling, we only need 95% of this energy is saving, and you only use 5% of the energy. This is, of course, we use only 400 degrees of energy, in terms of energy. This is the recycling rate. The lead is a high quantity because it's the lead acid of the cars, the batteries of the cars, and this is the advantage for doing recycling. Summarizing, why we need to recycle? Because the availability of metals is limited. Reduce pollution and conflicts in these countries. Why we want to recycle? To secure metal supply, to stabilize prices, to create jobs. Very important for the European country. But there are obstacles. And here we see the periodic table when we have, in terms of colors, the recycling rates of metals, and pay attention to this critical raw material. The recycling rate is less than 1%, and this is big problems. And the other problems are the problems with collection, and we have some things, some products have long lifetimes, some products are stored in our house. How many mobile phones we have in our home that doesn't work? The complex materials composition, the composition of materials is increasing, more heterogeneous. Under constraints is the problem, of course, of size, thermodynamic limitations, or the process of recycling are not perfect. An example that I can finish with, this specific example, in terms of rare earth elements. I think all of us know this problem. This is in terms of mining and in the processing, extraction and production of the metal for the process. And we know that the first producer in the world is China. 97% of rare earth elements comes from China. And if you know the problem in this moment between President Trump and the president, I don't know the name, because in the other day, the president of China was going to a mine of rare earth elements, probably to do a constraint of the importations of these elements. And there are an illegal mining of these rare earth elements in Africa, and this is the bigger problem. And the great problem also with these elements is the environmental problems. They are very dangerous for the environment. The process is also very difficult in terms of the work. There are only, in Japan, they have the processing, they don't have mining. Europe, we don't have mining, we don't have processing, we have only semi-final and final goods. In terms of trade, we have the evolution in terms of importations. Japan, of course, is the highest. Europe is like the second country, and from China was coming 90% of these elements comes from China. And the countries in Europe that imports, of course, countries that have production of these products that normally the mobile phones. Alternatives to the use of rare earth elements. One question that Professor Gisbert will speak about the changing the eco-design of the products, not in terms of the design, but in terms of other chemical elements that have the same function in the process. And we give also, for example, for wind turbines, how can we substitute the rare earth elements in the hybrid electric and electric vehicles, where we have, as you know, neodymium is the rare earth element there, for the lamps and also for the catalysts, but pay attention, no substitution is known. This is the great problem. Strategy, promoting green metal, recycling, cooperation between Europe and China, intervention in terms of mining because they are very pollutant, and progress in terms of science could lead also to the fluctuation of prices, and in terms of processing, develop new process in terms of recycling in new plants, and create a legal framework in terms of European Union for this great problem during probably these next 10 years. Thank you for your attention.
Thank you very much, Fernanda. It was really interesting and very urgent topics you are working on. Yes. So, unfortunately, I forgot to introduce you when we.
No problem.
Yeah, but you are a researcher at the Center of Innovation Technology and Policy Research and also coordinator of waste processing and management laboratory in Lisbon. So I think we just continue with the next speaker, and then we can have some time at the end just to, if some of you have questions and want to discuss it.
Thank you. Thank you. PowerPoints be available.
We can make the PowerPoints available. Yes.
Awesome.
So, and then this leads us also into next topic, design for industrial symbiosis. That's Gijsbert Kurovar.
Very good.
And Gijsbert is also a doctor and assistant professor at the Delft University of Technology on the Faculty of Technology, Policy and Management. And your research area is in design methods and tools for industrial symbiosis, business support and model for development of evolution of industrial clusters, and data support and data mining. So please, Gijsbert.
Thank you. Well, and thank you all for being here. Welcome. I would like to use this 20 minutes that I have to introduce a couple of concepts and projects that we have been working on in the past. So it's more like an overview of research that we have been doing at TU Delft, particularly in our faculty. And I linked that to circular economy as well. You see that I even changed the title. I took that freedom. I call it now Design for Circular Economy, but then inspired by industrial symbiosis research. And those are actually the two domains that I will talk about. Now, circular economy was very nicely introduced already by Fernanda, so thank you for that. I don't have to explain it anymore. And I will introduce what industrial symbiosis is. And as you can see, I always like this picture a lot. There's still a lot of debate on what circular economy is. So we just heard about one model by Stahel. If you look carefully, it is somewhere in this picture. But that means that there's still a lot of debate on what is circular economy, and I think the main reason for that is that circular economy in, let's say, its original meaning was more focused on products, and that's also what we just heard, and I think that's a perfect goal for circular economy, to think about recycling, reuse, remanufacturing, and those things. But people also try to expand it to regions and clusters of industries and cities even. And I think that's quite doable. You see that in all these frameworks, that somewhere it starts to expand. That's of course what I'm not going to explain in the slide, because you cannot even read all the details, but you see many frameworks. But in that expansion from a product to region to a cluster, I think still a lot of research has to be done. And that's interesting because we do research in industrial symbiosis, and that is particularly a topic that is linked to developments of networks and clusters. I will come back to that. It was also nice to mention this, because I didn't want to just criticize circular economy. I'm really in favor of the idea and the topic, but this is also an expression of, yeah, you see that right now, or that was in 2017, we can collect already 114 different definitions of circular economy. So I think also science has a role there to, well, think about new definitions, or one good definition that actually, well, will be an umbrella for all those different concepts and opinions. So what I now will do is I will focus more on that field of industrial symbiosis, and then see how we can take from that idea some, well, interesting insights for the circular economy. Now, the basic idea of industrial symbiosis, you can see it here in the graph a little, is that you have several economic activities. Could be companies, could be different institutions, perhaps an urban district and a company. So you do have different economic activities, and they are interlinked. So they exchange materials with each other with the purpose of, well, limiting the environmental impact. So it's about sharing services, it's about infrastructures, it's about information exchange. So industrial symbiosis is the concept of how can we bring separate economic activities that normally also do not belong together, perhaps in a supply chain or in one type of sector, but how do we bring them together so that they can use their resources and products in a more efficient way. Now in our faculty we do research on that, and I collected 4 projects, do more on that. I collected 4 that might be of interest for circular economy as well, and interesting to share with you today. So the first of them is the design of symbiotic networks. So what do we really need in terms of the design of such a network? So not so much the analysis of an existing network, but more the design of a new one. And for example, a project that we do is about urban symbiosis. That's again playing with words, industrial symbiosis, but in an urban context, urban symbiosis. And that means that in this case, you see an urban environment in which people need food, of course, so you do have urban agriculture as well, you do have consumers in that same network. And you see, of course, the different activities and how do they link together. So what this project is doing, and also what a PhD student that is working on it is working on, is to create a model that in the end will give us design insights to best optimize and design such a network. So taking into account that there's different actors, there's different types of technologies, there's different economic interests, there's different behavior even. So how can you take all those different things together to develop a new network, to design a cluster? Now that has been done then in a modeling environment, and then for today that I also stop there because I cannot explain all the details of that model, but if you're interested, you also can speak to me later. So it's also presented in a publication. We do this then in a certain type of complex adaptive models, agent-based models, in which you take all that information into account and then run simulations and see how they basically reflect reality. So that's one way to work on the design of those networks. Now another one that's also interesting, I think, is that we can understand how those networks develop over time. We call that evolution in this case, and you see that in this field of industrial ecology, industrial symbiosis and urban symbiosis and evolution, there's always those biological terms coming in. This is very interesting because you see that we can learn from ecosystems in different ways, and now also the network evolution or the network development is a topic that comes in. Now here you see again that modeling, and for example we did a project for the Climate Kick consortium, so that's about climate adaptation and mitigation, European project. We did this project on ENCORE, and ENCORE then stands for enabling CO2 reuse. So not only capture the CO2 and perhaps store it in the ground, but capture the CO2 and then use it for making new products. That is possible. You can actually make all kinds of plastics and all kinds of materials from CO2. Normally we never did that because fossil fuels were very cheap, and you need actually more energy to turn CO2 into a useful product. But now energy is also becoming more expensive. You see that it actually becomes valuable to capture CO2 and turn it in foams and rubbers and all kinds of fibers and coatings. So you see that in the short term, you might have to develop all kinds of new polymers. On the mid-term, you might even need to develop an entire infrastructure. In this case, you see that you need perhaps some hydrogen in the infrastructure to do so. Longer term, at some moment, that CO2 hopefully doesn't come from fossil fuels anymore, but is bio-based. And so in order to do so, you need, well, an entire infrastructure that supports all those ideas. And so we have worked on that project, and what we, for example, did is we made a very interesting, at least I found it interesting, interactive map. So those are all the spots in Europe, and I cannot zoom on in right now, but it's available on the website. So you can click on it and then you zoom in. You see all the spots in Europe from which a certain amount of high quality CO2 is released right now already. So you already know that from the stack of a factory, a certain high quality of CO2 is simply released right now. It's all within permits and it's all allowed, but it's a waste in terms of if you capture that, you could use it for chemical industry. That's then also one of the things that we do, and I think that's very interesting also for circular economy to know where the sources are and how we can better use them. I think also one of the aspects that we really need in more sustainability and circular economy is to know the assessment or the environmental impact before actually products are launched on the market. And so how can we do an early assessment of technology? Some people call it an ex-ante LCA, other people call it an early environmental impact assessment. No, but anyway, it's an assessment of emerging technologies. Now, for example, one of the projects that we do is on zero brine. That's an idea of brine is salt water, but it's much salter than seawater. So actually, mainly it comes from chemical industry. So you do have water with a lot of salt. And what we normally do is we dilute it, and then we dilute it as much as seawater, and then we release it to the sea. That is also what we do in the Netherlands, and I think that also happens here. But what you also can do is you can concentrate the brine, and then you get the water out, and then you get actually the minerals in a higher concentration. And that's interesting because you just heard about all kinds of scarce metals and so on. For example, in this particular project, we get the magnesium out of wastewater in the chemical industry in several locations in Europe. And that magnesium normally comes from mines in Russia. And so it gives us less dependency on Russia, even if we get the magnesium out in the systems in Europe, in the Netherlands and Spain and so on. And so what we do in this project is we do have this idea for new technology that gets the minerals out of the salt water, but then we do an assessment before actually the technology is released. The technology is still in a demonstration phase, so we're building it in the lab, but we already do the environmental assessment right now so that we can still steer the design of that new technology. Now the Zero Brine project, you also find on the website over here, right now has 4 demonstration plants in Europe. One is in the Netherlands, the other one is in Poland, one in Turkey, and one in Spain. And we will introduce the technology there, measure the impact, measure the energy consumption, and use that for the assessments as well. Now, one other concept, rather new, it's only about, let's say, around in the TU Delft for a year or so now. It's the e-refinery. It has some similarity actually with what I just presented on Encore, on the CO2 reuse. This is an idea of what if you would have a lot of extra renewable electricity, so intermittent available electricity. So if the wind is suddenly blowing harder or the sun is shining a little bit more, we do have more electricity. Can we turn that into chemicals? Because one of the main challenges we do have is how to store all that abundantly available electricity. Just batteries is not a smart idea. Other people are talking about just hydrogen. And this e-refinery concept is perhaps we can turn it into a little bit more advanced molecules. So you find here hydrogen, but also find carbon monoxide, methane, also formic acid. So there are those ideas to store the energy that we do have available in chemicals so that we can use that as base chemicals for the industry. Like normal refineries also work. This is then an electrical or chemical refinery, so an e-refinery. Now in that project we also contribute a lot in terms of that early technology assessment. So because a lot of those technologies are brand new, they're in the lab right now, so they all look great, of course. They're all sustainable, they're all efficient, and so on. That's what the scientists tell us. But what if you turn that into a more system perspective? Is it then still sustainable? And what if everyone would do it? And what if we would do it for a very long time? That's also typically the type of research that we bring in from our friends. Now, and one last thing that I also wanted to mention, is also an ongoing part of our research, not the most prominent one, but it's interesting, because we work a lot with industries, we know a lot about all kinds of different case studies. So we like to make more and more inventory of all those industrial symbiosis initiatives, and I think they are really an inspiration to circular economy as well. So circular economy is a new concept that appeared a couple of years ago. The idea of industrial symbiosis is already much older, so we can perhaps learn from those initiatives. So that will result in things like, we do have here a European study on the International Survey on Eco-Innovation Parks, containing information on all kinds of initiatives in Europe, and we can learn from that, and we publish that as well. So what I did is in a very quick way, I introduced you to symbiosis and circular economy. They do have quite some similarities, but also differences. That's all given in this table, but I will not tell all the details of that. You also can read the publication that is underneath it. But in general, you could say circular economy is more on products, more on companies, more on the economics as well. Industrial ecology or industrial symbiosis is more about clusters, networks, less on the economy and more on the environmental impacts. But on the other hand, they can still learn a lot from each other, and you also can see that in this table and further on in that publication. Now, and if you make an overview like this, and that's also a bit of an introduction to the research that I do and that we do in our group, but then of course the question is, yeah, these are the things that have been going on already, so what are the challenges? Now, I do have at least 4 new challenges that we work on and that we continue working on, because I think that the circular economy, besides all the work that is going on already, needs a better understanding of the system boundaries and the driving forces for network development, because you say circular economy is about products, but it also is about clusters and networks and cities even. I think we need to know more and we need to understand more what that means and how that works. That's something we can learn from industrial symbiosis literature or research, but it also needs more attention in our research. The second one I think is very important. Don't do only the assessment after the product is already on the market, and we can study coffee mugs for ages that they are, well, less environmental impactful than plastic cups or so, but it's much more interesting to do that kind of assessment before it starts on the market, and that's a very challenging job, by the way, because you don't know about many things, but you can make all kinds of estimates and reason about it. Now, the development of specific design methods that are not only focused on a good product, a feasible product, a nicely looking product, but also with special attention to services and value creation and ownership. And so design methods is, the development of it is an important topic still in our research. And well, a continuous further development of that inventory for the case studies on circularity and symbiosis. Thank you for your attention. If you want to know more, you can find my details.
Yes, thank you so much, but it was great. And it was a very good continuation of what Fernanda started with. So,
we didn't plan that we are in the same project. So.
Yes, but we didn't make so much planning for this, yes. So it was very good. And the next speaker is Margot Weinen.
Margot in English,
Margot
that's okay.
Is the Norwegian name, and we have known each other for many years. It belongs to them.
Oh, okay,
yeah.
then I leave
Yes,
it here.
yes,
Yeah.
it's about the streaming. Margot, she is a professor at the Technical University in Delft. She's chair of Process and Energy Systems Engineering at the Faculty of Technology, Policy and Management at the University of Technology. And her research is in process systems design, etc., etc. I'm sure you will explain this for everyone. And I would like to tell you a secret, all of you a secret, because in 1997, when I took my PhD, then she was the opponent. And fortunately I passed. So that's why you are here.
This
So
is your
please.
reward.
Yes.
I still feel guilty about making your life difficult. Okay, but that's yeah, infrastructure and sustainable development. You introduced me as a full professor of process and energy systems engineering, but I'm also, and that's the background, scientific director of a knowledge platform of infrastructure providers in the Netherlands, next generation infrastructures. And I think I'm not really presenting research work here, but it's more, you know, I would like to share some reflections on the importance of infrastructure for sustainable development, what requirements we should impose on infrastructure projects to ensure sustainability for the future. And I think it's really terribly important because infrastructure, and mind you, when I'm talking about infrastructure, it's not about just transport. It includes energy, it includes water, sanitation, communications, waste. So it touches on all aspects of the circular economy that Fernanda introduced. And you know, these are, and when I say infrastructure, then it's about the basis on the fundamental, the essential services on which we have built our society and our economies. And in fact, I didn't bring that material with me, but with Netherlands statistics, we embarked on a couple of studies into the value added of the infrastructure system, the combined system of economic infrastructure that provides us all these essential services, water, telecommunications, and everything. And that it turns out that on average, you know, over the years, it's around 12% of the total value added that the economy produces. In fact, at the moment, and that's still confidential, I cannot share these data yet, we are working on an international comparison that includes Norway. For Norway, it's a lot more if we include the production of oil and gas, which, if you're fair, should be part of the equation, because how can you produce energy services without harvesting something somewhere, whether it's renewable or not renewable. If you exclude that production part, then quite a different result comes out. But that's, of course, that comes as no surprise. But I think that in our endeavors into sustainable development, at least in our parts of the world, we often tend to take all these infrastructure services just as a given. You know, it's a fact of life. It's so reliable. We never have a reason to think about it. But as you have seen, only a couple of only last week Sunday on Father's Day, Argentina blackout, whole country simply power blackout. And I can just show you just 3 days ago a new UNICEF World Health Organization report came out about the water situation in the world. 2.2 billion people do not have access to safe drinking water services. 4.2 billion people do not have safely managed sanitation services. You know, these figures are appalling. In fact, in some parts of the world, these figures have been worsening rather than improving over the past 10 years, especially in sub-Saharan Africa. And that's also true for energy access, by the way. Only yesterday, I think, or today, only yesterday there were, I think, hundreds of arrests in Chennai, in India. People have been protesting, you know, they are lacking water. There is no water service. They have been protesting with empty water tanks, and they were arrested by the police. And in fact, the projections in India from an Indian government think tank now are that by the beginning of 2020, you know, in half a year's time, 100 million people in Indian cities, in New Delhi, in Chennai, and Bangalore, will be short of water, and on top of all the existing water problems that we already have. But I think for us here, it's, I think we all understand that infrastructure is very important in relation to the 17 Sustainable Development Goals. In fact, a more detailed study has just been completed and published in, I think, in the April issue of Nature Sustainability by the ITRC consortium. That's a consortium into infrastructure transitions research coordinated by Professor Jim Hall of Oxford University, and I think this particular paper was with Scott Thacker as the main author, so look it up. It's a very insightful paper that makes a much more detailed analysis of how different types of infrastructure are directly and indirectly important for accomplishing sustainable development goals. And it gives you a very convincing picture, yes. Infrastructure is very important indeed. And the problem, and it's not only directly, but also of indirect influence. And of course, we know that these goals are very much related. So without affordable and clean energy, we know it's also crucial in achieving health, in achieving food security, in achieving gender equality, education, and with education, economic development, etc. So that's no surprise. Well, energy access, because I just wanted to give a few examples from the energy area. By the International Energy Agency, it's defined as a household having reliable and affordable access to both clean cooking facilities and to electricity. And then the interesting thing is that for electricity, they say that should be enough to supply at least a basic bundle of energy services. That's a sort of absolute minimum. And then an increasing level of electricity over time to reach the regional average. So there is something dynamic here that changes with economic development, with social development. Because this basic bundle of energy services that is defined as a sort of minimum access condition for electricity is only about, powering several light bulbs, having a flashlight, being able to charge your phone and listen to a radio. That's the sort of the bare minimum, but we all know that this may be enough for if you leave for a nomad living in the desert, but for somebody who is a city dweller, no matter which part of the world, it is by far not enough. So there is this dependency also on what's the minimum. Also depends on where you live and how you live, and it also depends on the climate in which you live, etc. There are so many other conditions. Of course, the situation now is that I think a lot of progress has been made. I think in the past 10 years, at least 700, 800 million people have been given access to electricity. Especially in, so the numbers have now this year dropped just below 1 billion people. So it's about 1 billion people now in the world that does not have access to electricity, to this minimum, according to this minimum requirement. Of course, you can say that's tremendous progress, especially in China and especially in India, tremendous progress has been made. But also in terms of electricity, the situation has been worsening in sub-Saharan Africa. And in the entire world, there is still 1 billion people without access to electricity, which is appalling, I would say. At the same time, there's also the problem of access to clean cooking facilities. People need to eat every day. If you want to cook, you need energy. And still a lot of people do not have access to modern fuels and technologies that are not detrimental to health, and that do not take hours and hours a day for collection of, for example, firewood. Okay? And all this time spent on I'm just going too fast, but all this time spent on finding firewood cannot be spent on personal development, on education, and on productive activities. And it is, of course, always affecting the women and the children, which gives you a sort of vicious circle, a perpetuation of misery. Well, as I said, this minimum requirement for access to electricity is almost impossible to satisfy. Well, the minimum requirement may be possible to be satisfied without access to a grid, without access even to a microgrid. But as soon as you get into agricultural use, industrial use, into a service economy, there is no way you can do anything without access to the grid. That's the current That's the current situation. And of course, with technology, that may change. But this is the situation. So, and we see in many countries that cities are given access to electricity, but that the grid development into rural areas stays behind. Very often because it's not profitable, too low density of people. And as long as, and if we think that infrastructure development should be, let's say that it's just an economic assessment, and if we do this under a neoliberal regime where cross-subsidization between cities and rural areas is not allowed, then the rural areas are in for a hard time. This is the case in many countries. Let's not talk too much about the fuel mix. It's I think clear that the poor countries still depend very much on biomass, that the energy situation also goes at the detriment of the environment, and that in the most advanced countries we have access to cleaner fuels. Otherwise I'm going to take too much time. And this is another example of, this is in fact showing how many people in various countries still rely on biomass for cooking, and how many hours people spend on average per day, finding the fuel for cooking. Point is, these practices, inefficient cooking with very inefficient stoves in a closed environment, cause millions of premature deaths every year. It's very polluting. But if this much about energy access, the last thing I'm going to say about this is that energy access is not only about physical access to, and some energy infrastructure system that is providing you services. It's also about, yes, it is about physical access, and the point is that physical access is usually lacking in countries where people cannot afford to pay for it. But we see that also in situations where people can afford to pay, they don't get the service. Here, as in these countries, there are many people above the poverty line who are not serviced. And this is because of structural issues, regulations, corruption maybe. This is an institutional, based in the institutional dimension. Okay, this much about access. Sustainable development and infrastructure requirements, it all starts with access for each and every citizen. In addition to access, there are a few other requirements. And let me just say, I usually group them into acceptability, which is health, safety, and environment, but also many other aspects, more social. There's also a social and an ethical dimension to acceptability. It's about affordability, which I already mentioned, and it's about availability, which I'm not going to talk about too much, but that's about reliability of service on a shorter term and a security of supply, with a longer time horizon. I just happened to spend the last summer, fortunately it was the summertime in Mongolia, was there for a couple of months. But Ulaanbaatar has a very bad reputation. It's one of the most polluted cities in the world during wintertime. I can't. Out of the total population of about 3 million people, more than half live in the capital city. But they don't live in normal homes. They just took their tent from the interior of the country, brought it to the capital city, and set up a new life there. They may have some electricity connection, but it's very weak, so they can't use that to heat their homes electrically, but then the whole system would collapse. The city was designed as a city for maybe 500,000 people, but now houses 1.8 million or so. So all these homes are heated with a very, very poor quality coal, you know, with a very inefficient stove. And this is what creates abnormal air pollution in the city in the wintertime. So that you can't see, that you can't breathe. And it's so far above World Health Organization requirements that, you know, this is, what do you do in a situation like this? What should the government do? The government last year said, we are going to forbid the use of poor quality coal. Everybody will be obliged to buy better quality coal briquettes. And of course the briquettes were not available and everything failed, and the situation was the same again this winter as it was the winter before. So this is you know, one of these challenges of infrastructure planning. Just a very another dimension of acceptability. As I said, it has also there are also non-physical aspects, non-environmental aspects. It's also about fairness. It's about justice. It's about also about transparency in decision making, about legitimacy of decision making. Here are just two of the these photos are from Germany. Consequences of lignite mining, and these are from the northern part of the Netherlands. Consequences of natural gas production in the Netherlands. And in the Netherlands now we have a strong feeling that it is not fair, not just to let the people in Groningen suffer, you know, to bring gas benefits to our economy that we all benefit from. And so there is a very strong feeling of solidarity that we, yes, should stop natural gas production in this part of the country, the sooner the better. And the political decision has in fact been made. And so this is a very clear case of what we say energy justice. This energy justice thinking comes from environmental justice concepts, but energy justice has many more dimensions. Then affordability of energy services. And this is something many people, my students are always surprised, you know, that this is not only a problem in developing economies, in less advanced parts of the world than ours, but that affordability of energy services is increasingly a problem in the Netherlands and increasingly a problem elsewhere in Europe, you know, in many very advanced economies in developed parts of the world. And so we are more and more worried about issues of energy poverty and about issues of transport poverty, by the way, too. It's somehow the social dimension of infrastructure system services have not been on the agenda for quite a while. I think since we introduced the neoliberal paradigm in the 1990s, you know, somehow we thought that the market would solve everything, that the market would ensure a fair distribution of costs and benefits, would ensure good prices, affordability for everybody, and good quality of service. And it doesn't. But we find now that it doesn't. And I have seen some fantastic case studies from countries like Bulgaria, but unfortunately there is no time to go into that now. What you can see is that, no, you cannot see it here, but the point is that many countries still use very different indicators for energy poverty. Usually, you know, very often they take a threshold, you know, 15% of expendable budget of household income, but different countries do use different indicators, and sometimes they use several indicators. What you can see is that all the Nordic countries, Finland, Sweden, certainly Norway, are on the right side. And apparently you don't have any problems with energy poverty here. But in some parts of Europe, yes, Poland, Greece, also in Germany, even in the Netherlands we are getting into problems. You know, energy poverty is a real and more and more urgent problem. And it's of course made even more difficult because it's not something that you can solve within the confines of energy infrastructure and the energy sector, because it's also related to the quality of the built environment. What is the quality of the home that you live in? And that's an important factor in keeping it adequately warm. It all boils down to an action of the EU to start an energy poverty observatory in January 2018. So this is a place, it's in fact more of a website than a real physical observatory, where information on energy poverty and energy affordability is collected for all different European countries, and where you can at least find a lot of data based on primary indicators for energy poverty, and there are at least 20 secondary indicators for energy poverty. A lot of research is in fact being unleashed, I think, by the mere fact of this EU Energy Poverty Observatory. Just a little before the start of the Energy Poverty Observatory, the European Pillar of Social Rights was signed. And I find that, at least in a European perspective, a very hopeful sign that we are rediscovering essential services is something that is not a given. That is something, in fact, how I read Article 20 of the European Pillar of Social Rights is a recognition that, in fact, infrastructure-based services are essential for everybody, that they are a social right for every European citizen. And in fact, in a global perspective, you could say infrastructure services are part of human rights. They are so basic for each and everyone. And it's about reliable and affordable service of drinking water. It's about sanitation, energy, transport, communications. The one I was really surprised about is the financial services, because I see that as a service at another level of hierarchy. But it's also, I don't know how it's going to be implemented in European law, if it is going to be successfully implemented. But they also say that support for those in need should be, given to ensure access to such essential services. And this is in fact the idea that I would like to leave you with here. All infrastructure, infrastructure is not about asphalt, it's not about a railway, it's not about pipelines for transport or cables that transport something. Infrastructure is ultimately, it's only useful to think about infrastructure if you think about it in terms of services. And then these services are equally essential for each and every business and each and every citizen. Because without it, how do you participate in society? How can you contribute to the economy? It's all starts. So there is an obligation, on the government side to ensure access. And we used to have universal service obligations for good quality infrastructure-based services, but we have somehow let it slip in certain areas. For example, in communications, there is no rule in place now in the Netherlands that says that all of the Netherlands should have the same quality, the same high quality of, let's say, broadband speed, or something like that, or broadband capacity. So what we see is that there are regional differences now, or differences between cities in the quality of infrastructure services that they provide. Basic criteria for infrastructure, I think for infrastructure in relation to sustainability are therefore access. It's about availability, affordability, and acceptability. And how to balance those, because of course we can see that availability and affordability are to some extent conflicting criteria. How to balance those that's ultimately a political decision, because there are values at stake here. And values should be part of the public debate, should be part of the political decision. You know, how did we start a discussion about privacy? It's because we are talking about smart grids, about personalized services, about intelligent infrastructure nowadays. But fairness, justice, inclusiveness, now these are values to be acknowledged in the political debate. Transparency, legitimacy, these are a part of what we would say procedural justice. Does everybody have a chance to have a say in the debate? Is he or she heard? Or are certain rights perhaps not acknowledged in the political debate? In the end, and that's why infrastructure is important for a sustainable development. Infrastructure is, I think, nothing more or less than the fabric of our society. It's okay. Sorry. It may seem rigid, but it does allow us to change, to evolve, and so. And I would like to conclude with the statement that infrastructure is never a goal in itself. We have to realize it's only a means to accommodate the society that we want to be. That is what the debate is ultimately about. And personally, I would like to add that I hope that it will be an inclusive society.
Thank you so much. I think this really gave us the big picture, starting from the smaller perspective and then ending up on the big, some of the big characters we see in front of us. We have a few minutes. We have another meeting that starts at 1 o'clock again. So, but we want to have a group photo, and we also want to. You can ask questions here. If you have any questions to the presenters. Everything was made very clear.
Everybody's tired.
And we send around a list that we want you to sign up, because we also have a project called Smart Circular City. And when we count meetings, we also count them on different projects, you know. So we need to have a list of participants for the different meetings. So, but I will thank you all for meeting up on this seminar. It was on very short notice, but I think it was very great to have this opportunity to organize this seminar. And in this Smart Circular City project, we're also building up a knowledge base on how to transition to more circular thinking, and also to the infrastructure, and also to see how we can build more sustainable systems within our city. And we have one from Ålesund Kommune here today, and the Ålesund is the first smart sustainable city in Norway belonging to the UN Smart Sustainable City program. And yesterday we had a workshop here at Campus Ålesund, where we have the first United Smart Sustainable City Lab in North Europe. We have one in Vienna, and this is the second one. So, and our strength is on simulation. So we have already made a model on a digital twin of Ålesund Kommune, and we are now using this and to look into different scenarios for future planning, and this will be used to plan the new commune. From 1st of January next year, we are now in a process where we merge 5 municipalities into one larger one. So it's a very interesting process going on, and we have the NTNU has an agreement with the new Ålesund Kommune about collaboration, and also create it as a university municipality. If you have something to add on this project, it could be nice just to inform people here.
Where should I start?
You can say the enthusiasm that has been created here in Ålesund because of please come forward
Should I
and
go forward?
yes, and introduce yourself.
My name is Tom Ryan. I currently work with the Planning and Building Department in Ålesund, and we started this journey, I should say, September last year, and it's just gone really fast, and the enthusiasm is really high because we know that all the topics that you talked about today about circular economy, about inclusive societies is really important in the future because one, we don't get any more resources, especially what you said about the rare earth metals, and also we are seeing that on the new municipal, the new area and transport plan, we are seeing that political processes are getting more and more difficult for people to understand. So we are also working on a project with simulation and NTNU to basically make planning processes easier to understand, so people actually can feel that they can be involved in how politics are formed in the municipality, because we are seeing that is also a big problem. And all the UN system is getting, it's also important for us to get, let's just say, outside influence and ideas, because we know how to do some things good, but not maybe everything. So getting outside influence is also good in making a more sustainable society for us.
Yeah, I was just curious when you say include people in the planning processes. Of course, we all try, and then we organize all these hearings in the Netherlands, and who is there? Only white retired men. And the rest does never show up and is not heard in the process. So that's our typical picture. But I was just wondering, I have seen very exciting examples of how people can be effectively drawn into these processes in a way that works for them and for the planners. It's through serious games, for example. Are those techniques or approaches that you have been trying?
We have not tried them yet, but we are very, very aware, and Helsingfors have used for planning in school projects, used Minecraft to great effect.
Yeah.
So we are also looking into that and how we can use that, but it's really early start, so we are getting
it's
there.
interesting, but it would perhaps be interesting.
In Australia, before
Yeah.
when I was working, we used there was a research project I was part of called the Urban Dashboard or Urban Pins. So it's basically social comments when an area is under development. People come in and they they make their comments. It's more effective than going into these scary political meetings for them. I mean, it's maybe not effective because you don't take the comments as seriously. But there's
I've seen some really exciting examples from India, and in fact, it is a small not-for-profit company that started doing this in India, has also been invited to the Netherlands, with similar games, to engage in some of the neighborhood discussions that go on. In the Netherlands, we now have big debates about how are you going to heat our cities without natural gas.
Also, I've been working with the KPIs, Smart Sustainable City, basically the benchmarking. I've been working with collecting the data. I'm actually going on Monday to Rijs, so I get to help them. So
Okay.
But what you said about old tired white men that should have logged out of Facebook, we have the same problem. And also I think using social media as a platform is good, but it's also a bit scary because for young people, they don't use Facebook anymore because
there are too many of the parents and grandparents.
Parents on it, so they don't use it. So using Facebook like a benchmark is beginning to be a bit scary because you don't get the right voices for developing your society. So we have a job to do, and it's really important that we get this right, because if we don't develop our society with good interaction with our citizens and who are we designing cities for.
Yeah, it's a real challenge.
But this is also now a part of capacity building and get people to understand
Yeah.
these challenges.
Yeah.
So this is something we as NTNU, we collaborate with the Ålesund Kommune and also the Sustainable City Lab, and to be involved both in technological solutions but also in building knowledge. And it's capacity building among our students and also to develop our curricula so we get more of the sustainability stuff into the curricula as such and not only as a separate
Yeah, yeah.
teaching. I think that's important.
I